In this video, we're going to show you how to calculate all of the unknowns in a basic series circuit. We have an R1 here, which is 220, R2, which is 390, and an R3, which is 560. We're going to use the chart method here, which helps us to organize and lay out all of our needed information. So the first thing we want to do is we want to write down, basically copy, the known values. The first value that we know is R1, which is 220 ohms, R2, which is 390, R3, which is 560, and our voltage total, which is 20 volts. Now, the first step typically in a series circuit is to go ahead and try to figure out your resistance total. And that's very, very simple. It's basically R1 plus R2 plus R3 plus how many ever resistors there are after that point. In this case, this is a three resistor series circuit. So we're basically going to come through and add all of these up. And when you do that, you should come up with 1,170 ohms or 1.17 kilo ohms. We'll just keep it in ohms now because we're going to need that value to help us do the next part. The next part is to go ahead and figure out your current in a series circuit. Now, current in a series circuit is really easy. All you need is a voltage and your resistance total to calculate out your current total. And the thing about current in a series circuit is it is the same at every point, or what we like to say in my class, in a series circuit, current is the current. So once we're going to calculate out our current total, we will take 20 divided by 1170. I'll give you a second to calculate that out. And you should come up with 0.0171 amps, or 17.1 milliamps. Now, because current is the same everywhere in a circuit, because current is the current, I can fill the rest of these in here. Okay? Now, because current is the current, I now know the current through R1, R2, and R3. The next phase is to calculate out all of the voltage drops for each individual resistor. Now, we know in a series circuit that the sum of each individual voltage drop must equal your voltage total. The voltage total is given here, so we can mark that on our chart here. All right? And then we need to apply basic Ohm's law to calculate out what the voltage drop is for each one. So, for the first one, we take our current, which is the same everywhere, multiplied by the individual resistor, in this case, a 220 ohm resistor. When you calculate that out, you're going to round to about 3.76 volts. That's going to be the voltage drop across here. The next phase is to calculate the voltage drop for R2. We take the current multiplied by 390, and we should get 6.67. The next phase is to calculate out the voltage drop across R3, which is 0.0171 multiplied by 560, and you should get 9.58. Let's take a second to analyze what we've just done. So, our largest resistor gets our largest voltage drop. Our smallest resistor gets our smallest voltage drop. This is a very quick mental check you can do with these systems, just to make sure you haven't made any simple mistakes, typically typing in numbers incorrectly onto a calculator. Now, all of these should add up to be pretty close to 20 volts. Now, if you add all these up, you actually come up with 20.01, and that extra hundredth of a volt basically comes from the way that we rounded here. If we would have taken this one number farther, we would have been almost dead on with 20 volts. That's definitely within tolerance, so we're good to go. The next phase is to calculate the power that each one is consuming in this circuit. There are a number of power calculations that you can use to figure out the power for R1, R2, and R3. But the easiest one is power equals voltage times current. So we're going to take our current multiplied by our voltage, and when we do that, we're going to come up with roughly 0.0643 watts, or 64.3 milliwatts. Calculate out the next one. Again, voltage times current, and you come up with 0.114 watts, or 114 milliwatts. For R3, we want to calculate the power dissipated there. We multiply 0.0171 times 9.56, and you're going to come up with roughly 0.164 watts, or 164 milliwatts. Now, to figure out your power total, there are two methods you can use. You can add all of these up to get your power total, or you can multiply your current times your voltage. And when you do that, you should come up with 0.342 watts, or 342 milliwatts. There are a couple of checks at this point that we can do to make sure that our math is correct. For example, we can come back and take any of the voltages that we have, and voltage drops that we have, and divide it by the individual resistor. So if I were to take 9.56, if I were to take 9.58 and divide it by 560, I should come up with really close to 0.0171. That's a way to verify and to find out your current if your voltage total isn't known. So that's how we use the chart here to find all of the information that we need to understand what's happening in a series circuit. Hope you enjoyed. Thanks.